Welcome back for CPW Science Round 2. This week we have 4 questions. In our first question, we're going to perform a simple interpolation using data in a table. In question 2, we're going to identify similarities and differences between models. In question 3, we'll compare or combine data from 2 or more simple data presentations, in this case tables. And in number 4, we'll understand the methods used in a complex experiment. So we're going to know we're successful when we can, 1, determine an appropriate response based on a data table with data that's actually not there. We're making a prediction. And number 2, we'll compare and contrast different experimental models. In number 3, we'll analyze the results from the 3 experiments given to determine an appropriate response. And our last question, we'll have to apply basic chemistry knowledge to determine the right answer. In our first question, it asks, if a trial had been done in experiment 3 with 0.06 moles of NaCl added, the maximum temperature increase of the mixture that would have occurred within 15 minutes would have been closest to what? So, to be really honest, the ACT doesn't really care about what science you've taken so far. It just really wants you to read tables and graphs and be able to kind of justify responses from different passages. So if a lot of you freaked out because you don't know what a mole is, this is just a unit like kilograms or grams or puppies. It really doesn't matter. It's just signifying the amount of something. So the other issue is that 0.06 moles of NaCl, I see that the similar verbiage is in this table, but 0.06 is nowhere in the values given. So I would have to either mentally draw a line or physically draw a line in the data table so that I can see where the temperature possibly could be. So looking at the table, my range is from 34 to 50 because 0.06 in between these two values. So it's not going to be 34, because that's the value for 0.05. It's not going to be 50, because that's the value for 0.075. And it's not going to be greater than 50, because those responses would be more appropriate for something above 0.06. So the correct answer to number 1 would be B, because that's the only answer left. Also because that number is in between 34 and 50, so there's really 2 ways to kind of figure this out. Our next question asks, which of the following factors affecting the reaction of magnesium and water was studied in experiment 1, but not in experiments 2 or 3? So in this question, we're looking for the differences between experiment 1 and the other 2 experiments, which implies that experiment 2 and 3 have a similarity between them. So our first option is reaction temperature. So I went ahead and color-coded the potential responses here. So reaction temperature, but in all 3 reactions, there are experiments, the reactions are done at 20 degrees Celsius. So A is out as an answer. B, the addition of sodium chloride or table salt. All 3 experiments have the addition of sodium chloride, so that's also out. C, the addition of iron. All 3 experiments have iron added, so that's out. So that only leaves D, the surface area of magnesium, which is the correct answer. But I want to point out that it's pretty subtle inside the experiments in themselves. So in experiment 1, the word ribbon is here. That means that it's more of like a wire substance. But in experiments 2 and 3, it's powdered, meaning it's crushed. So that would affect the experimental rate because the smaller the pieces of something, the faster the reaction will go. So the point of this whole experiment, according to the passage, was you're designing these heaters to heat rations used in the military. So if an engineer is designing an FRH to be used with 100 milliliters of water that will most rapidly generate the greatest amount of heat. Okay, let's take a pause here. It's asking the most rapidly. This means the fastest. So we want to cook our food efficiently. So we want to generate the most amount of heat, the fastest, with the least amount of materials, because we don't want to waste a whole lot, because we could use those materials for something else. So we're looking for the perfect combination of materials to generate a lot of heat very quickly. So, but in order to do that, we have to look at all 3 experiments. So the first factor is you're looking at the iron powder. And we're looking at either 0.05 moles, which again, doesn't matter, it's just an amount. So just take it for what it is, versus 0.7. So in order to find that information, I have to find the experiment that goes with iron powder, which is experiment 2. And it says, 0.5 moles created 66 degrees of heat, and then 0.7 moles also created 66 degrees of heat. So if it gives me the same amount, because clearly the temperature is plateaued, I'm going to go with the lesser amount to save on materials. So C and D are both out as options. The next factor, 0.125 moles of NaCl, okay, they're the same in both experiments, so I can actually just ignore experiment 3. I don't need to worry about that at all, and I don't need to worry about this at all either. So the last piece is that we have 0.1 moles of magnesium powder versus 0.1 moles of magnesium ribbon, which is coming back to that first experiment and this really sweet looking graph. So magnesium powder has a more steep slope than the ribbons. What this implies is that powder reacts faster than the ribbon. So again, we have 3 things here. I want to generate the most amount of heat with the least amount of materials, but also do it the fastest. So ribbon is out, which leaves A as our final answer. Because powder reacts faster than ribbon. And the last one, you have to know what a catalyst is for this particular problem. Because it's been observed that as magnesium and water react, magnesium hydroxide, which is one of the products that is produced, forms an unreactive coating on the magnesium surface. Which of the following models for why sodium chloride speeds up the reaction is the most consistent with this observation and the results of the experiment? So sodium chloride speeds up the reaction when it's just added. However, this implies that it's something called a catalyst. And a catalyst speeds up a reaction, but without becoming part of the reaction. So you'll notice that in this reaction, sodium chloride is nowhere in here. It just acts as something to speed it up. So last year in biology, you learned about enzymes, and enzymes were biological catalysts to speed up reactions happening in your body, but then could be reused later. So in chemistry, which is what this passage is focusing on, sodium chloride acts as similarly as a catalyst. It speeds things up, but then kind of goes along its merry way, and I can separate it out later if I really wanted to reuse it. So because it doesn't become a part of the reaction, when I see the word reacts, I know these 2 options are out, because as a catalyst, sodium chloride isn't reacting with any of these things. It's just kind of helping it along. The same goes with the word binds. Binds also implies that sodium chloride's reacting with it. So that option's also out, which leaves A as our best answer. So in this week's CPW, to recap, our answers are 1B, 2D, 3A, and 4D. Until next round, guys.